There's an organ in your chest that starts shrinking almost the day you're born. By the time you're old, it's mostly fat. It peaks when you're young, then quietly withers for the rest of your life. And that vanishing little gland trained the army that keeps you alive. That gland is called the thymus. So what does a shrinking organ actually make? And why would anyone turn it into a medicine? Think of the thymus as a training school. A school for your immune cells, specifically for T cells, the soldiers that hunt down infected and abnormal cells. Baby immune cells arrive raw and untrained. The thymus teaches them what to attack, and just as importantly, what to leave alone. Get that second lesson wrong, and the immune system can turn on the very body it's meant to protect. So this little school has very high stakes. It runs the whole program using a family of signaling molecules, and in the 1960s, one scientist set out to find them. His name was Alan Goldstein. Goldstein and his team pulled a crude extract from the thymus and started splitting it into fractions. They were looking for the active ingredients. One of those batches, they simply called it fraction 5. It could stir the immune system back to life in animals that had lost theirs. So the hunt was on. What exactly inside fraction 5 was doing the work? Out of that search came a whole family of molecules they named thymosins. And in 1977, Goldstein's group isolated and mapped one of them precisely. A small peptide, just 28 building blocks long. They called it Thymosin Alpha-1. In the lab, it did something striking. It appeared to wake up tired immune cells and help coordinate the body's defense. Now here's what makes this story different from most peptides people talk about online. This one didn't stay experimental. Thymosin Alpha-1 became an actual regulated medicine sold under the name Zadaxin, also called Thymalfasin. It's approved in around 30 countries. Doctors there have used it for chronic hepatitis B and hepatitis C, liver infections, where a tired immune system struggles to clear the virus on its own. The idea is simple. Don't attack the virus directly. Sharpen the body's own defenders and let them finish the job. It's also been studied in sepsis, the dangerous, body-wide overreaction to infection, and given to help steady the immune response in some seriously ill patients. So while most peptides in these stories are still chasing their first solid human trial, this one has decades of clinical use behind it, and that reputation drew serious attention during a crisis. When COVID-19 hit, doctors noticed something. The sickest patients often had their T cells collapse. Their immune army was running out of soldiers. So researchers asked an obvious question. Could a molecule that boosts T cells help? In 2020, a team led by Yu-Ping Liu studied 76 severely ill patients. They published the results in the journal Clinical Infectious Diseases. The patients given Thymosin Alpha-1 had a lower death rate, and their exhausted T cells appeared to partly recover. Promising? Yes. Proof for everyone? Not on its own. It was a look-back study, not the gold standard kind where patients are split at random and compared. That matters. One study, in one crisis, is a lead, not a final verdict. It's a reminder that even a molecule with decades behind it can still surprise the people who study it. So let's keep it straight. Approved in some countries does not mean approved everywhere. In the United States, Thymosin Alpha-1 is not an approved general medicine, and the versions sold on the gray market online are not the same as the regulated pharmacy drug. Same name on the label, but very different quality control. Even real. Approved medicines have limits, side effects, and plenty of cases where they simply don't work. And a peptide that nudges the immune system is not automatically something a healthy body needs nudged. This is a science story, not medical advice. No dose, no source, no how-to here. Now, one last thread. Remember Alan Goldstein, who found this whole thymosin family? One of the other molecules his work uncovered was thymosin beta-4. That's the healing peptide behind TB500, which we've covered before. Same gland, same scientist. Two very different jobs. One tunes healing, the other tunes your defenses. Which raises the strange part. The thymus makes all of this, and then spends your whole life shrinking away. By middle age, it's a fraction of its former size. Doctors even have a name for it. Thymic involution. And here's the unsettling link. As that gland fades, older bodies fight off new infections less well. Why would your body deliberately dismantle the school that trains its own defenders, right when it might need them most? That's the thread we pull next. So think again about that little gland in your chest. quietly vanishing since the day you were born. It isn't failing. It isn't an accident. Your body seems to be shutting down its own immune academy on a schedule, and no one is completely sure why. Thymosin Alpha-1 is one message that school left behind. The bigger mystery is why the school itself was built to close. Thanks for watching Brainstorm Bob. If this made you think, hit subscribe for more curiosity, ideas, and real answers. See you in the next one.